Today I would like to show you my backtest of results of reinforced learning algorithm. So I did some improvement, and let's look in on my file. Just analyze traits. Okay, and so how it's working. So I download data. I create some levels. Then you see, for example, results its folder, and there exists some name of files. It's number of epoch, and then I could looking for entry traits, exit, and what is the time of duration, and then I can build all epochs when the trait is successful, and let's compare. So I did this backtest from scratch. It means without any reinforced learning algorithm. It means there, and inside in my trading simulator I input this data set. What is the strategy? Yeah, it is loss. And then what is the features, and without agent. And let's look in agent. Okay, and I will need to find what is traits null agent. And you see, this is some profit line. We have some good profits, then the profit is stick, then again is increase. In general, the strategy provide 55% of profitable trades, and average profit is 0.05. And loss, it's too big. It's some base strategy, and then when I run it using reinforced learning, I can achieve some results that would be more than 7,000, like this one, yeah. And there the profit line is more smooth, but there is not enough trading epochs because I have too many trades, and I need to hold this training more time. But in general, I know it's working, and it is good news for me. And then I need to working on the agent. Let's explain. So first of all, I used some Bollinger Bands signal. You see, I created too many different signal, and I tested from scratch and with agent. Okay, let's look in what is, yeah, and I tested for the last 3 months. So some window, Bollinger Bands, so it's not difficult. You just define a standard deviation and plus standard deviation and minus level minus standard deviation from our rolling, moving average, and just create some signal there. But inside in our environment, we trade it with reinforced learning. Okay, so how I did it? A long time I couldn't achieve any positive results, but I'm working on reinforced learning, and I did some improvement there. Let's look in there. So this learning trader, we have only one neural network inside in this learning. This one, you see. So this one is our Q table. It is a 2D array, and inside in this Q table we find the best policy user neural network, and we do all times updating this policy, and using this policy the algorithm trying to make decision. But what I did, like additional step, I create additional neural network. It's feature extractor, and you see it's a very simple neural network without any convolutional neural network or LSTM transformer. I just input a state and trying to extract useful feature. And for example, in this case, I do output 32 features, and then I input this feature inside in this neural network. Let's look at it. You see, we take batch size. Yeah, and this stuff very influence on my results. If memory would be mini batch size would be more than 100, I achieve better results. If I used a very small batch size, this results with noise, with some noise, dispersion. Okay, and you see I have states, action, rewards, dance, because if we have stop trading, why we have stop trading, I'll show you. In my case, I just create some very hard rules. If I have minus $100 of my deposit, I stop trading. So this algorithm trying to trade with positive balance from the first trade. But in the future, we need to improve this one. I mean, I need to do some rolling drawdown from the high of our profit line. Okay, and then then I do scale states. Also I do scale rewards, and this one I do feature states, and next I do next key values and calculate this target, and after that I extract this useful feature and train both neural network. But this neural network, it's some non-traditional approach. I just input scale states and trying to optimize rewards, this one. All times we collect memory inside our memory block, and I'm trying to train a neural network, find how many rewards I can achieve for using the states before previous experience. And then I can train, I can input this outputs, means from this neural network I do output 32 features, but we can improve this one. Okay, so it helps me to solve this problem and achieve some positive results. But what else? So this neural network is very simple because I need to create some base version what would be working. Because if I create some very hard neural network, it would be too hard to understand if would be something wrong. But I know some base models working, and then I would like to create instead of this dense layer, I would like to input convolutional neural network and extract some patterns from them. Okay, And let's look in what would be on the results. Okay, I can show you. Yeah, I forgot. It is very important. I need to explain about this Q-learning. So let's look at this Bellman equation. You see, we have alpha, and we have gamma there. I remember for you. So gamma, it's influence on the rewards in the future, in the long future. It means if gamma would be 1, it means this neural network trying to optimize rewards to achieve rewards in long term. If gamma would be 0.1, it means the agent trying to optimize this Q value to find action to achieve a reward what could be exist in the next few steps. And using alpha, we do calculating how often we update our Q value. And it means sometimes we need to update a policy, yeah, because if we have a bad experience and we need to update this alpha with a high coefficient, but if working is good for us, and it means we shouldn't update this Q value. But right now, gamma and alpha is constant value, yeah. But we need to create some function what would be decreases alpha and gamma. You see, it's like update epsilon. It's very simple, and I need to create additional function to update this alpha and gamma. Okay, so but on production I'm not going to use this neural network Q-learning trader, because I explain because we have some unstable results. If I implement double Q-learning, it means it would be a true neural network working, and I can achieve more stable results. Or for example, if I implement actor to critic model, it would be working better, I think, in this case. But we need to test everything to understand that it's working, and if would be something not working, we will understand where we have a problem. Okay, and let's look in. Okay, I show you how it's working. Test trading. Okay, and let's look in on this one. I would like to uncommit. Okay, and loss it would be $100. So let's wait in. It takes some time, but useful to understand what happens. Okay, right now we create a feature, Bollinger Bands, and another additional feature, and here we will have some current profit. Yeah, I forgot something. It's very important. It's about rewards, how we calculate rewards. Instead, we have rewards. I'll show you. We have rewards there. Yeah, but I input my rewards of my total balance, because I would like to train this agent with my total balance. It means before that I used reverse for each trades, yeah. But right now this algorithm trying to analyze dynamic of my balance instead of reverse for each separate trades. Okay, you see we have a backtest, and I save these results like no agent. We have number of trades, percent of profitable trades, and also some average profit. Okay, and then I run this neural network, and you see we have epsilon, and this epsilon is decreased. For example, right now it's 30. It means in 30% of cases we have some random action to explore our environment. There, if you have some open trades, we calculate what is the current profit. It's for me just to analyze. Okay, let's wait and take some time. For example, I think in these cases we have stop loss because we have $100. We stop trading if we have if we decrease balance less than $100. Okay, very smallest trades. Okay, I would like to just input trades 0. It would be maybe 1 trade or 2 trades. Yeah, 2 trades, and you see less than $100, and we stop trading. And we reset this epoch. We stop this epoch and try to trade another epoch with this experience. Let's look in 1. Okay, it's the same, but right now trading is successful. Let's wait and maybe it takes some few minutes. Okay, yeah, and of course I need to create some clever update policy because I didn't like this policy. You see, for example, this epsilon is decreased to 0.10, means 10% will be random actions, and then if you achieve less than 10%, I reset this epsilon to 20%, because I'm trying to create agent with more exploration, okay, to explore my environment. But in general, epsilon policy should be very clever, and it is a very big piece of work. I need to create some clever function and to understand how it will be working better. Okay, and you see, for example, current profit means if you move to our environment on some step, we calculate what is the right now of profit, for example, $14, $66, and then agent make decision. Oh, okay, I would like to close, sell. Yeah, all times close, sell, sometimes close, buy, sometimes yeah, I create actions. I want to close, it means agent I want to close if it doesn't matter, buy or sell. But sometimes this agent could choose the action. It would be buy, close buy signal, or sell signal, or both. It doesn't matter. Okay, let's wait in. I think it would be interesting for you. Yeah, and you know, right now it would be a third epoch, and in this epoch, the agent haven't experienced, yeah, because the previous two epochs we close after 2 trades or 3 trades. Let's look at um, like this one. How many trades? 10. Okay, 10 trades, and in August. Okay, I think it's working not bad. Okay, let's waiting. um, in general, we can decrease epsilon to 0, and it means for each next step we make decision only from narrow network without any exploration. But it is very difficult to find balance, yeah, between exploration and prediction. Okay, epsilon 0, some profit. Okay, sometimes you have negative profit, positive profit, it's okay. Okay, it takes some time. I just cut off video. Okay, guys, so we finished 2 trades, and it was too many trades. And let's look in on the results. What happens is really interesting. Okay, it's something not bad from the first epoch, but it's still worse than our base strategy, because our base strategy, let's look in again, it would be okay, agent we achieve is about 7,000, but right now 5,000. Right now we have less, but after too many backtesting we will create some good Q table with a good policy, and using this policy we can predict quality signal. But for me right now I need to make too many tests, and then after this test I would like to implement another neural network. I mean agent like actor to critic or double Q-learning. Okay guys, thank you for watching this video and see you next time. Bye.